Hello, my name is Peter. This is Dev Suvara, and I am going to continue the journey into artificial chemistries. Our previous conversation about this was a little while ago, where I discussed some of the principles of what artificial chemistries are meant to do and how they're kind of transforming the way that you use the language of chemistry and then using the language of computation to create a simulation. So I want to dive in on just right now to discuss the idea of model and simulation and how we're going to approach the idea of creating an artificial chemistry by setting some founding principles. Essentially, in any kind of artificial reality that we have, we need two things. We need a model of that reality, the data that comes in, and we need a simulation, a process that goes through and actually does the work. And that's what the simulation is. So a simulation what we're going to do is similar in the way that you might have a loop or a set of recurring processes, is that you have something which happens over time, and that simulation takes in data, and then we'll process that data, and then we'll loop again on that data until we get an outcome. And what the point of that is to just define exactly what it is that we want to do with our simulation. So we want to create a certain set of algorithmic processes that take in a model and then return a model that then gets processed again and again and again. And the system updates essentially on a computational machine. Now, because we're using computers to do this artificial chemistry, it doesn't really necessarily matter what we're going to be working in. It doesn't really matter. The language itself is not that important. But I think for the ease of use and just to make it easier for everyone to understand, uh, because Python is a really expressive language, it has really embedded itself as the language for academia. It would be wise, I think, to use Python. So um, I'm well versed in Python, so we're going to use Python to define the data. We might do it in JSON, we might do it in Python structs, but probably do it in JSON. The model itself will be in JSON, and the processing and the simulation itself will be executed in Python. Now, if we need to optimize, if we want to run something really fast, we might, because I'm using a Mac, we might find ways to run things on the GPU through Python, perform certain Metal is the layer that does the mathematical computations for graphics. So we might use some of that compute engine, the GPU engine, to process things. So we're going to run that simulation in Python. And the other thing is that the idea behind simulation, this is kind of like, now that we've got those things out of the way, the idea behind simulating things, and we're not going to be able to get exactly what we want out of the simulation as we would say, for example, in reality. So if you perform a chemical reaction in the real world, it'll be different, obviously, than in a simulation. It's not the same thing. They're just different things. But the idea is that we can explore ideas with chemistry in ways that we may not be able to do so in the real world. And we can also try and find ways to maximize the understanding that we get from the simulation that can then help us understand how the real world chemical reactions work. So this way, we're kind of creating an engine to help chemical engineers discover things. We're not trying to build like not necessarily a predictive model yet. We may or may not, like it may not be the right approach, but we want to simulate chemistry, right? So this is like, I just want to preface this. Won't have really anything to do with AI or anything like that. We're going to try and create simulations of chemical reactions, of chemistry, so that we can learn about the chemical reactions and the possibilities. So that way we might find ways to explore new places, new things to access, new information within the real world. So guys, I think next week I'm going to dive into some more chemistry topics. I want to kind of keep moving this forward. In the meantime, I might do some other videos about dev topics I'm passionate about. But until then, I'll see you at the next video. Thanks for tuning in. Bye.